coming in hot. Coming in hot.
Hello everyone and welcome to today's tutorial. The question you have been given is to draw a locus of a point on the periphery of a circle, which rules from the inside of a curved path. We have to take the diameter of the rolling circle to be 50 millimeters, and the radius of the directing circle, that's the curved path, to be 75 millimeters. And the name is called the hypocycloid. Alright, so before we start anything, we first have to find the angle the rolling circle is going to turn, and that's given by the small r over big R times 360. So the small r in our case would be 25 and the big R would be 75, so that will be 120 degrees. So let's start drawing. So I'm first going to draw a vertical line. Then I'm going to mark a point. Then with the help of my protractor, I'm going to mark out 120 degrees. So that's my 120 degrees. But then we all know with the divisions of the circle, that's the rolling circle, we have to divide it into a number of parts. In my case, I'm going to divide it into 12 parts. So meaning I'm also supposed to divide the angle into 12 parts. So 120 divided by 12 is 10. I'm going to mark out 10 equal angles or degrees. So here's my 120. So I'll mark out 10. So now I'm going to draw a line through all of them. This is the first one. Alright, so now we have a marked out division. Now you are saying, the question was saying the directing circle has a radius of 75 millimeters. So let's measure out 75. That's 75. I'm going to start at the midpoint and draw an arc. So that's the directing circle. Now the rolling circle has a radius of 25. So let's mark out 25. Oh, sorry. Then I'll stand at this point and inscribe an arc. Then I'll now stand here. So right now we have our directing circle and also have our rolling circle. Now let's divide our rolling circle into 12 parts. So I'm going to draw a vertical line through. So we have 4 parts already. Now let's send it to 12. So let's try now. The same radius I stood here to draw, sorry. I stood here to draw this. That's the same radius I'm using to mark out at each of the 4 corners. Now I'm going to draw lines through the marked points, through the midpoint. Alright, in that case, our point B is at the top here, point B. So I'm going to start numbering. 1, 2, 3. Next, I'm going to get my center point arc, or so I'm going to stand here, open to the center point. The center point and draw an arc. So that's where I'll be making all my markings. So let me number that one too. So that's 1, 2, 3, 4, 5, 6, 7. Right, next I'm going to stand here, open to 7. We'll pass through 5, 2, and draw an arc. Next I'll open to 4. We'll pass through 8. Now draw an arc 2. That's my arc. Next one is 3. 3 and 9. This one is 2 and 10. And finally 1 and 11. Alright, so we have our arcs. This is our main center line. And we have our arcs. Alright, so next I'll stand at the center point here and open to this radius, or this point, point P. That's my point P. Next, I'm going to stand on line 1 or center 1, and inscribe an arc on line 1. That will be here. Next, center 2, and inscribe an arc on line 2. That will also be here. Center 3, line 3. Line 3 is here. Center 4, line 4 is also here. Center 5, line 5 is also here. Center 6, oh, we didn't draw one for 6, so let's draw it right now. So we open to 6. We have this arc. Next, let's go back. P, step at 6 and inscribe an arc on line 6, so that's here. Then 7, that's line 7. Then 8, that's line 8. Alright, then 9, line 9 is here. Then 10 is here. 11 is here, and 12 is there. So now let's mark it out where we had the arcs. Alright, so we are going to join all the points with the freehand curve. Right, and that's how to draw a hypocycloid.